will come back to the last part of 10.2. I also don't anticipate that we'll necessarily finish 10.3 today, and I have to just look at the schedule since we're down 4 days now. I'm going to see if I can make it up in Unit 3. If not, we just lost our final exam review. So we'll see. All that time at home has its downside. So what we're going to work with today is the product rule, and we're going to use this to simplify our harder radicals, the ones that aren't perfect. So first thing we're going to do is just show, using numbers, that the product rule holds true. So let's look at the square root of 9 times the square root of 4 versus the square root of 9 times 4. So we actually did a problem very similar back in 10.1, but we used addition. And we saw we didn't get the same answer. In 10.1 we had the same example but with addition, and we got two different answers. So the square root of 9 times the square root of 4. Well, what's the square root of 9? 3. Times, what's the square root of 4? 2. So 3 times 2 gives me an answer of 6. And if we have them both under one square root, we're going to start by multiplying them together. So the square root of 9 times 4, if I multiply those together, I get the square root of 36. And the square root of 36, they're the same. So what we're going to do here, two things. We can always multiply two radicals together and make them one radicand. And if we have one radicand, if we can find products for it to split it up, we could also do that. So we can put them together, take them apart using multiplication. So our first set of problems is to use the product rule to multiply and simplify if possible. So when I see a square root and I multiply it by a square root, the product rule says it's okay to multiply those radicands together. So it's okay to multiply the 5 and the 7 as long as I keep it under a square root. So square root of 5 times the square root of 7 is just the square root of 35. You can multiply two square roots together. So in B, the square root of 17x times the square root of y. Since they're both square roots, I can multiply them together. I can multiply the two radicands together. Make sure you keep them under a square root. So I get the square root of 17xy. For C, I have a cube root times a cube root, so I can multiply them together as long as that answer starts underneath the cube root. So make sure you keep your radical. And I'm welcome to multiply, and we'll see in another lesson, divide radicands. But those are the only operations that work, multiplication and division. So I have the cube root of 2 times the cube root of 32 is the cube root of 64. And the directions also say simplify if possible. Can I simplify the cube root of 64? Yeah, what's the cube root of 64? 4. So radicals are like fractions in that from now on, every time you have an answer, you've got to make sure it's simplified. And that one's perfect, and in a little bit, we're going to get to the ones that aren't perfect and learn how to simplify those. In D, we have a 4th root times a 4th root. Same radical, you're multiplying. Multiplication's okay. Just multiply their radicands. Keep them underneath a 4th root. So 6x squared times 3x underneath a 4th root. So I get the 4th root of 18x to the 3rd. And so I'll tell you that that's completely simplified. And we're going to now get the reason why that's completely simplified. So the question is, how do you know when it's completely simplified? How do you know when it's done? These are some of those problems where people are like, oh, do I want to keep going? Do I not want to keep going? Christy.
The exponent inside the radicand is smaller than the index.
Index. So we talked about that one before for our variables, and that's perfect. So when you're looking at variables, you know you're done when the exponent is less than the index. So on that last problem, my exponent on the x was 3, the index is 4, you know I'm done. If they're equal, you can still simplify. If it's greater, you can still simplify. But if the exponent is less than the index, we know our variables are done. For numbers, no perfect, and then it could be square, cube. That depends on the problem. If it's a square root, you're looking for a perfect square, cube root, a perfect cube. So no perfect can divide the radicand evenly. And this is where that chart of numbers comes in. So I'm going to have to... So if you have 10.1 out, you've got that table. You'll see your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81. See if you're familiar with them. It doesn't take much to make that list. Your perfect cubes are 1, 8, 27, 64, 125, 256, 343. 216. I get that one wrong. 56 is a 4. Thank you. It's my first time this year writing them. A little rusty. All right, so what we're going to be doing for numbers is we're going to try to break them up as a number times a number. And what we want is we want one of those numbers to be from this list. One of them has to be from this list or it doesn't help us. Because once we have a product, we can simplify just half of it if that's all we can simplify. So our first example is the square root of 200. We want to simplify that. Now the square root of 200 is not anywhere on our list. If you throw it in your calculator, you get a decimal, so that doesn't help us. So what we're going to do is we're going to use this idea of the product rule. It has to be a product. It has to be multiplication. No addition, no subtraction, multiplication. So I'm looking for two numbers that multiply to 200, where one of them, it's a square root, so one of them is a perfect square. So I'm trying to break up 200 as something times something. One of them has to be a perfect square. Add them. 100 times 2. So 100 times 2 is 200, and half of that, only half of it will be, half of that is a perfect square. So what I'm going to do is I'm going to break this 200 up. It's still under a square root as the square root of 100 times 2. Because my product rule says as long as you're multiplying, it's okay to break it up. Now, which half of that can I simplify? The square root of 100 or the square root of 2? Square root of 100, the half that's the perfect square. So the square root of 100, since it's a perfect square, I can simplify it, and that simplification's out front now. So what's the square root of 100? 10. So 10's outside, so I can simplify it. And what are we leaving behind underneath the square root? So I'm going to have 10 times the square root of 2. Now you've got to be careful because when you break these up, you're always looking for the largest perfect square. So if not, you might have to repeat the process. So let's say you said, well, 200 I know is 25 times 8. And you're like, okay, that works because half of that's a perfect square. So then I say, well, I can simplify the square root of 25 so it comes out. Your perfect squares are out front. The square root of 25 is 5, and then what's left behind is the square root of 8. But do any of my perfect squares evenly divide into 8? Do any of those perfect squares evenly divide into 8? 4. So I know I'm not done. That's what I said with numbers. Your numbers aren't finished if any of your perfects still divide into them. So I know the square root of 8 is not simplified because I can divide it by 4 evenly. So then I'd have to go again and say, okay, I can break up that 8 to be 4 times 2. And then my perfect there is the square root of 4, so that comes out front. Now what do you think happens with the 5 and the 2? Multiply them. Everything in these problems is multiplied. So if you've got to go again and you bring something else out front, you multiply it. And 5 times 2, there's my 10 square root of 2. It just took me longer to get there. So that's why I just look for the largest perfect square first. Always start at the top and work your way down. And if you have a calculator, the fastest way to do this is to approximate on your list. Now, I don't go as far as where 200 would be. I guess there's only one more between 121. So what you would do is you'd say, okay, 200 on my list is about here. If you had the full list, it'd be a little bit easier. So you'd grab a calculator. This is a very quick process. You only divide the perfect squares. Don't start dividing 200 by 3, by 4. Take a calculator, 200 divided by 169. No. 200 divided by 121. No. 200 divided by 100. Yes. You've got your pair. So don't waste your time guessing pairs. Use your list of numbers. Use that list to find how to break things up. So B, I have the square root of 18. It's not on my list. It's not a perfect square. So I want to try to find if I can break it up as something times something, where half of that is a perfect square. Do any of my perfect squares evenly divide into 18? 9. 9's the only one. So I can rewrite the square root of 18 as the square root of 9 times 2. And then what half of that can I get out of the square root by simplifying it? The 9. So when I simplify the square root of 9, it comes out front as what number? 3. And then left behind, square root of 2. Now, why would I not want to simplify this by going, okay, 18 is 6 times 3. Why wouldn't I break my 18? Because the square root of 18 is the same as the square root of 6 times 3. They're mathematically equivalent. They're not a perfect square. Neither of them is a perfect square. So you've always got to make sure when you're finding these products that one of the numbers is a perfect square that I'm going to be able to simplify and get out front. All right, C is the cube root of 40. So make sure you're always paying attention to that index. We're no longer looking at our perfect square list because we have a cube root. So we're going to shift over to the other list, perfect cubes, and see, do any of my perfect cubes evenly divide 40? So using my list of cubes, do any of these numbers evenly divide into 40? 8. Okay, 8 times what gives me 40? 5. So I'm going to take the cube root of 40. I'm going to break it up as the cube root of 8 times 5. And then what part of that can I take out front? 8. And what does it come out front as? 2. The cube root of 8 is going to come out front, and that's going to be 2. And then left over, don't forget your index. We have a cube root of 5. Questions? And again, if I had my calculator and I wasn't sure for 40, I'd say, okay, if I look at my list of cubes, 40 would be between 27 and 64. So I'd take my calculator, I'd say 40 divided by 27 doesn't work. 40 divided by 8 works, you're done. So there's not a lot of guessing here. And I didn't used to, but you get on your drills, on your test, everything, your yellow cards. Your yellow cards are your tables of perfects. Gotta know how to use them, but I will provide you with those numbers. So you will have that as a reference. So if you're using your table on your homework, you'll have something similar for your drill. Just gotta know how to use it. Now variables are a little bit different. They just have a different rule. The concept is completely the same. I'm going to break it up. So variables, what's the rule, section 1, your extra credit questions. What's the rule for simplifying variables under a radical? What are we trying to do? Devin. Yeah, we always divided our exponent by our index. So for variables, what we were trying to do is divide exponent by our index. It has nothing to do with your table of perfects. It has nothing to do with your yellow cards. It's straight division. I could give you any index with a variable and expect you to simplify it. It all has to do with division. Well, what is the exponent, sorry, not the exponent, what is the index on my square root? 2. And every other time we were able to just take the exponent and divide it by the index, but 5 doesn't evenly divide by 2. So I'm actually going to show you 2 ways, and I want you guys to pick which way you want to do all the problems from now on. So first way we could do this is to break this up into 2 different x's. Now I still need to account for 5 x's. I can't change the fact that there are 5 x's in this problem. So what's the Price is Right rules? The number closest to 5 without going over that I can divide by 2. 4. So that means that my perfect square is actually x to the 4th. So 4 is the closest number to 5 without going over that I can divide by 2. But if I'm still accounting for 5 x's, how many more do I need? I've got 4, and I need 1. So I'm going to break it up just the same I break up a number. Half is perfect, half is not. And then how do I simplify the square root of x to the 4th? Or what do I get? X squared. So you take the 4, you just divide it by your 2, and you get x squared out front, and then underneath my square root is x to the 1st, or just x. And how do we know that this one is completely simplified? The exponent's smaller than the index. So my exponent on this x is 1. My index on a square root is 2. So we know we're done. Now, there is another way, which is how I used to teach this when I taught at a different college. So we're trying to divide 5 by 2. So this is an OR situation. It doesn't work out evenly. But think back to your basic math. Let's set up 5 divided by 2. How many times can 2 go into 5? Twice. Remember long division, and we do 2 times 2 is 4. We subtract, and we have 1 left over. So back in basic math, you'd write this is 2 with a remainder of 1. Whatever divided evenly is the exponent on the outside. Whatever your remainder is the exponent on the inside. So you'll see the 2 tells me x squared on the outside. The remainder is how many x's remain underneath, 1. So however many times it evenly divides, that's how many x's you have on the outside. Whatever your remainder is, that's how many x's are on the inside. Initial consensus. Does one of those make more sense than the other? The which one? You like the first one? First one? Okay. I usually teach the first one. I just didn't know if people would prefer the other way. So we'll just break everything up. It's consistent as well. But again, it's a completely acceptable way. If you just divide, however many times it evenly goes in, it's on the outside, whatever your remainder is on the inside. Just another way to do it. All right, E, the cube root of y to the 8th. The first thing you should always check for is see if you have something that's perfect. Don't waste your time breaking it down in that case. So is the cube root of y to the 8th perfect? Got to vote for yes? Another vote for yes? Can I talk anyone out of it? What do you think, Kevin? Perfect or no? Think it's perfect? If it's perfect, what's my answer? Y squared. Okay, but what do I say about variables? What did I even write down? I'm supposed to divide. And this is why I put this example on here. As soon as we start talking about perfects, you're all looking at that list. You're looking at, you got a cube root, I see an 8, I'm good. It doesn't apply for variables. When you've got variables, turn this upside down. Don't look at the board for those numbers. It's purely division. Can I divide 8 evenly by 3? No. Got to break it up since 8's bigger than 3. So let's go with that first method. So it's still a cube root. Don't forget your indexes. Still a cube root. Now, 8 doesn't work, so I'm going to break this up just like I break up numbers. I'm going to need some y's and some y's. So what's the closest number to 8 without going over that I can evenly divide by 3? 6. So just start counting down. 8, can I divide it by 3? No. 7, can I divide it by 3? No. 6, can I divide it by 3? Yeah. So we know we want a y to the 6th. That's going to be the largest perfect cube we can get in there. But if I've got 6 y's, how many more y's do I need to account for all 8? 2. So y squared. So that's how you break up variables. And then what is the cube root of y to the 6th? Y to the 2nd. Just do 6 divided by 3. And then what's left over is the cube root of y squared. And how do I know that cube root of y squared is simplified? The index is larger than the exponent is smaller than the index. So I have y squared times the cube root of another y squared. Questions? All right, F. First off, that negative sign out front. What's that negative sign out front going to do to my answer? Just going to be a negative. So we're just going to slap a negative sign out front. So negative. Now we've got 3 different things we've got to work on breaking up. The number, the A's, and the B's. So 72. We're looking for the largest perfect square, if any, that will evenly divide into 72. So if I'm sitting at home and I'm looking at my list, I'd say, okay, 72 is between 64 and 81. If I'm not sure, I just grab my calculator. I do 72 divided by 64. No. 72 divided by 49. No. 72 divided by 36. Does that one work? Yeah. So then I've got my pair right there. And it took me putting 3 things into a calculator. So 72 comes from 36 times 2. Now how about a to the 4th? Is that perfect? Do I need to break it up? It's perfect. Why? I can divide the exponent by the index. Don't look at that list of numbers for the variables. Just I can do 4 divided by 2. So I'm not going to break up the a to the 4th. But I'm also not going to simplify it yet because I've still got everything under a radical. So I like to make 1 radical, 1 simplify. And then, accidentally simplify things twice. So the a to the 4th we're just going to bring down because I don't need to break it up. And then how about b to the 9th? The square root of b to the 9th. Is that perfect? can't divide 9 evenly by 2. So we're going to do the same thing, break it up. So I'm going to need 2 different sets of b. And now we've got to decide what their exponents are going to be. So I'm looking for the closest number to 9 without going over that I can evenly divide by 2. 8. So 9 doesn't work. If I just count down 1, I get to 8, which I can divide by 2. And how many more b's do I have to account for? There we go, 9 b's. And now, how many of these factors, these are actually factors because they're multiplied, how many of these factors can I simplify? How many of these 5 are perfect? 3 of them. So the 36, the a to the 4th, and the b to the 8th. They're all going to end out front. So I still have the negative sign just kind of kicking around. The square root of 36 is 6. For your variables, you're dividing your exponent by your index. So I'm going to have a squared, b to the 4th. And now I still need that kind of dumping ground for everything that couldn't come out front. So I need to set up a square root for anything I didn't circle, anything I didn't simplify. So things I didn't circle or simplify, 2b. So they stay under the square root. So I'm looking at negative. My negative sign's kind of floating. Let me bring that back down. Negative 6 a squared b to the 4th, square root of 2b. Questions? This is like factoring that it's going to be in the rest of chapter 10. All right, so we have one more example. What do you think that big 3 out front is doing? What do you think is going to happen with that big 3 in the end? It's not an index. It's not a cube root. It's not the little 3. Multiply it by 3. So whatever I get for the rest of the simplification, I'm just going to multiply it by 3. So the big 3 is just going to hang out front 3 times, and then let's work on the radicand. So 75 is not on my list of perfect squares. Do any of my perfect squares evenly divide into 75? Yes. 25. It's the only one. If more than one divides, you take the biggest one. So 75 comes from 25 times 3. How about a to the 25th? Is that perfect? Can I just bring it right down, or do I need to split it up? Split that up. So variables, and the reason I put all of these examples on here is these are the ones that people get confused on. 25 is a perfect square if it's a number, not an exponent. Exponents, variables, it's just division. Can I divide 25 by my index of 2? No, so I've got to split it up. So when you come to your variables, turn your yellow card over, put your table away. It's just division. So I'm looking for the number closest to 25 without going over that I can evenly divide by 2. 24. So just start counting down. 25 doesn't work. Count down 1, 24. It's even, it divides by 2. With square roots, you should only have to count down one number, ever. Ever. So if you're at an odd number, you go down 1, you're at an even number. So 24, and then how many more a's do I need? 1. So a to the 1st. And then how about b to the 7th? Just bring it down or break it up? Break it up. 7 doesn't divide by 2, so I'm looking for the number closest to 7 without going over that I can evenly divide by 2. 6. So b to the 6th, and then b to what power? 1. So this time we actually had to break up everything. We couldn't just bring something down. So let's go through now and simplify the ones that I've got. I always write them first. You don't have to. All of those perfects. So I've got the 3 times from the original problem. And then what's the square root of 25? 5. So 5 comes out front. What's the square root of a to the 24th? Just like 12? A to the 12th. So we just take the 24 and divide it by 2. How about the square root of b to the 6th? B to the 3rd. So we just take, again, that 6 and divide it by 2. And then what's going to be in my leftover square root? There's more than 3. There's 3 AB. And you think I'm ready to box that answer yet? Multiply by 3. So my final answer is 15 a to the 12th, b to the 3rd, and then the square root of 3ab. Yeah. Say it one more time.
The 3's you had times the 3 times 5.
Yep.
But then the 3 inside.
No, think of it as protection. You can't get through that square root to multiply. Yeah. Anything out front only multiplies with things out front. Good question. Any other questions? All right, go ahead and try these 2. Let's do a square root of 48x to the 3rd and a cube root of 1 So let's do the cube root of 81 x to the 6. Go ahead and try those 2.